Ricky Chair. All right, here we are back again, everybody. I stopped instead of paused. Sorry, so there'll be two videos.
Almost done. I'm sorry, I'm blind. I cannot see.
All right, so now we have moved on to equivalent equations. These are equations with the same solutions. And I have written two examples over here. You can just check my examples real quick, and then I'm going to pause the videos while I'm doing this. X equals 7 and 2x equals 14 are equivalent. They have the exact same solution. Okay? Does that make sense to you guys? If you simplified this one, it would simplify into x equals 7, right? So even though they're written differently, they are equivalent. They have the same solution set. Okay? Okay, so moving on, you have the addition principle. And really what it basically says is that you can add or subtract the same thing to both sides of an equation, and the equation will remain true. And for the sake of the recording, I'm going to go ahead and say, I'm going to use this example that I used the last time, and I'm going to add the same thing to both sides of this equation. So if I said x plus 3 equals 7 plus 3, this is me adding the same thing to both sides of the equation, so the equation is still valid. Okay?
Equals 7 plus 3.
Okay, so we're going to do another example, and this is, we're going to have this equation given to us. It is x plus 5 equals negative 7, and we want to solve this now. So what I would want to add to both sides is really a negative 5. So you're adding a negative. So we're really going to subtract 5 from both sides. As long as I do the same thing to both sides, it's going to be okie dokie, right? So now we're going to say that x equals negative 12. And that's us using our addition principle. Pause. All right, our next slide tells us that we have a multiplication principle with equations, and that simply means that you can multiply the same thing on both sides of the equation and it would be true. And just real quick on here, I can't write on my screen, but that should say that c does not equal 0. Okay, so just put a little slash through the equal sign to say that c cannot equal 0. I really should go back and fix that. And then you have this equivalency of if a equals b, then a times c would equal b times c. We'll look at an example. We have an equation, 5/4 x equals 10. I want to multiply both sides of this equation by the same value so I can solve for x. So I'm going to multiply both sides by the reciprocal of the fraction that's in the problem already. So we'll multiply both sides by 4/5. All right, that's going to clear the coefficient on this side, giving me just x. Two ways that you could approach this is to go ahead and multiply across, which would give you 40/5, which reduces to 8. Or you could simplify first and say 5 goes into 5 once, 5 goes into 10 twice, 2 times 4 is also 8. Both approaches are valid. All right, the last thing we'll talk about is multiplying by a -1. And I'll just give you an example. If I had -x equals -4, you simply multiply both sides of this equation by -1, and it will change the sign of x and give me the positive answer that I'm looking for. So we would consider using the multiplication principle, multiplying by a -1. Now this becomes positive x, and this would become a positive 4. Okay, so just if you needed to change the sign, you simply multiply everything by the -1. You just have to make sure you do it all the way through. Okay, so if you had multiple terms here, you would multiply everything by the -1. Does that make sense? All right, so looking at our homework, looking at your homework, which is, you know what, I'll go ahead and raise this so you can see the problems.
We got page 86.
Page 86, I'm going to turn this on. In just a minute. So, yeah, here are your problems. And they're going to ask you if a given number is a solution to an equation. And so I'm going to give you an example of that. They give you this problem that says 6 minus x equals -2. And then it's written like this. So what they want to know is 4 a solution to this? You're going to plug 4 into this equation and see if it makes it true. That's what they're asking you to do. And so you're going to have problems 12 and 13 that are those types of problems. And it's just going to be a yes or no answer.
Wait, sorry.
Because what they're asking you is 4 a solution? And it either is a yes or a no. In this case, what is the answer?
Yeah. No.
It is no, right? Because if you put 4 in, you'd have 6 minus 4. It does not equal -2. So this answer is no. Yes, ma'am?
Do you have to show any amount of work or just yes or no?
On these, it's just a yes or no. Because they're really simple. The rest of it, I expect you to show me some work. Okay, that makes me very happy. That was a great question. Then 24, 34, 42, they're asking you to solve. That's using the addition principle. And then you'll use your multiplication principle on the rest of your problems.